Point following is great and all, but it has one major flaw. There is no way to follow multiple points in a smooth way. And when doing an autonomous run, smoothness is the difference between actually retaining a game piece in your robot and getting the chance to score it, between losing the game piece and missing out on potential points. We don't want this to happen, so we need to look broader. Let's go back to geometry actually. What do 2 points form? That's right, a line. What if we could process the point as an array of lines? Each line contains a start and an end, which are 2 definite points, but there are infinite points in a line. So we could leverage that in order to make the ride smoother. But how do we know which point of the line is optimal? Enter Pure Pursuit, an algorithm meant to answer this exact question. In theory, it is actually pretty simple. We use a circle with a center point, the robot, and we see which lines intersect with the circle, at which points. And if there are 2, we just basically choose the optimal and discard the other. Now, in practice, the implementation can be very tricky. That's why it's all implemented in Cyan. How do we use the integrated Pure Pursuit of Cyan? Well, first of all, we need to get rid of this thing, this ugly sequence, and create a path object that takes as the parameters the points of the path. So we're going to use the same points we previously used. And we're pretty much set on the path end. But now we need to prepare our follower in order to follow the path. So let's do that by doing follower.purePursuitSetup, and it takes 2 different parameters. One is the look ahead distance, which is the radius of the circle we are going to create. Now, listen closely, because look ahead distance is a very important one. A smaller look ahead distance means that the following is going to be more accurate, but it's going to be less smooth. So a greater look ahead distance is going to have a smoother following, but it's going to be less accurate. So the logical decision for me here is to just put a random number, because it's an example. Again, it's going to need a lot of tuning and testing in order to get this correct. And admissible error is basically the same as the tolerance. So let's just put 20 here. For the follower to actually follow the path, we're going to do, instead of follow point sequence, follow path, and pass in the path we created earlier. And that's pretty much it. Now you're probably wondering, my autonomous isn't simple like that. It needs to leave objects and stuff like that.